Hello, everyone. Welcome to today's webinar. Today we'll talk about Matter. As you know, the open source standard for connected home devices. And to talk about Matter, we have our technical marketing manager, Anant Gupta. Hello, Anant. How are you today?
Yeah, hi Pedro, I'm good. How are you? How's the day?
Yeah, I'm good. Thank you. So we have this first webinar of a series. I know that you are going to talk a little bit more about this Matter webinar series. So this is the first one that we are doing about Matter. So I think it's a quite important topic to talk and to explain to our customers and how they can get started with Matter and actually what is Matter and why Matter is so important, not only for Espressif but for the whole IoT and connected devices ecosystems.
That's correct, right? So yeah, so this is the first session, and then we have a couple of more sessions leading on to it, which talk in more details about building a Matter device, and then the third session would be about certification, device certificates, and what all you need to do to get your device onto the market. So yeah, so we have a series, and this is the first one.
Yeah. So the stage is yours. So let's start and talk a little bit about Matter. Thank you.
Sure. Thanks, Pedro. Yeah. So, welcome everyone. Thank you for joining and taking our time for our Matter webinar series. And today is the first session for it. Today, we will talk about introduction to Matter. So, what all we cover today is going to be the following. Uh, So we try to talk about why, what, and how. So why do we need Matter, what it is about, and how it solves the problems. Then a little bit more about the Matter network, the topologies, the device types, etc. Then we go a little bit more into the Matter data model on how the Matter devices are structured and how they communicate and what all information they store or what are the commands, etc. Then we talk briefly about the key features which bring the differentiation of Matter and how it helps or how it improves the ecosystem as well as the user experience when people use Matter-enabled devices. Then we talk about the current status. So, how is the market adoption? How is the ecosystem adoption? Where does Espressif stand in its view and the status of the devices there? And then in last, we briefly talk about what all Espressif has to offer in terms of Matter, the number of devices, the hardware, SDK, as well as complete solutions and the status, right? So, yeah. So let's get started. Firstly, why, what, and how, right? So the problems it addresses and how it addresses, right? So let's look at the current challenges in a development cycle for a Matter device, or not a Matter device, but for any connected home device, right? So suppose there is a idea from a company or a maker that I want have an appliance, I want to have an idea which I want to add some connectivity to it and operate it with a phone app. I said, okay, this is pretty straightforward. I will just need a phone app and a device firmware. But then the moment you think of phone app, it comes, okay, I need to support both Apple ecosystem as well as Android ecosystem. So I need a phone app for both App Store as well as the Play Store. Okay, that should not be a problem. Um, but what do I have to do if I want to control the device from outside the home? Oh, then I need to have cloud connectivity. When I talk about cloud connectivity, immediately a lot of things come into picture. The security aspects to it, and then which all cloud connectivities to support to, what all ecosystems to support to. So if we just take a simple example of the most common three ecosystems of smart home, which is Google, Alexa, and HomeKit, it means you need to have a cloud backend support for all three of them, even a device firmware integration for the HomeKit, because HomeKit is a local protocol which runs heavily local on the local network, whereas Alexa and Google Home are cloud connected. So you need to always go to the cloud to understand what is the skill and then do the appropriate action. So it already has complexity. And the next part comes is, okay, I also want to have some assistance integration to it, right? So I want to let my smart speakers control my device or control something, right? That adds another bunch of complexities, which is voice assistant skills you need to maintain, develop, as well as contribute to it. So yeah, so overall, what started as a very simple thought process, it in the end, for a commercial viable device, it becomes little complicated to develop, right? And of course, it comes with its own challenges of cost as well as bugs and etc. Right? So let's look into more details at why we need Matter, right? So this was from the device maker's point of view, right? Now from the ecosystem and the consumer's point of view also, right? So from a consumer point of view, there are right now a lot of silos in the same house, right, with multiple ecosystems due to personal preference of different family members, right? So suppose I like Apple, my wife likes Android, so yeah, I have to support both of them, right? So yeah, so that's the first part. And then finding a product which works with your ecosystem could be a challenge, because when you are going to buy just a smart light, suppose, right, you have to say, okay, I work with Google, so you have to check whether it says works with Google HomeKit, or my wife says uses Alexa, so you have to check whether it says works with Alexa, right? So all these challenges come into picture. And most often, suppose if you want to say, oh, I now want to switch over, I'm now bored of this ecosystem, or I don't like the features or some concerns, I want to switch over to a new ecosystem. It's virtually impossible to do it right now. So yeah, unless you bring in all new devices to start over again, right? So yeah. So these are some of the challenges which the consumers face. The device makers, we discussed little just in the previous slide, that what are the challenges the device makers have, but yeah, they also have a longer development cycle, complex designs, multiple SKUs to support different topologies, different technologies, and whatnot, right? So it's quite complicated for device makers as well. And then also for the ecosystem vendors, right? So how to deal with customer complaints of inoperable devices in their ecosystem because of lack of interoperability on the device side, security standards being very different across various vendors, so which could be a security threat for the overall ecosystem. And then if you want to integrate with multiple different vendors, it adds to the complexities on the ecosystem architecture as well. So all in all, the current landscape of the smart home is highly fragmented, right? So every ecosystem working on its own, every device makers have to make a choice which ecosystem to support. Consumers need to have a choice or decision maker, okay, which ecosystem I want, or which will be the most uh, easily portable ecosystem or most commonly used ecosystem for my house. So it's quite some challenges across the complete life cycle of the product, right? So yeah, so this is why I think Connectivity Standard Alliance came in together with all the major ecosystem players, major device makers, as well as other silicon vendors to come up with this protocol called Matter. So what is Matter, right? So it's an industry unifying standard defined by the Connectivity Standard Alliance. It was formerly the Zigbee Alliance. It has more than 200 members, which are contributing actively towards definition of this protocol, right? So what are the principles on which Matter is defined, right? So first is simplicity, right? So it wants to make life simple for end consumers, life simple for the development of manufacturers, right? So we want to remove the complexity. If it's simple, it's better. It has to be reliable. It should work and consistently work, right? So that's what you need as a user experience. So Matter brings in something like a local network, so you can even operate even when your connectivity is out, so you are not connected to the internet, but your devices could be able to talk. Then there is a certification process which is defined, which makes sure and ensures that all devices which are Matter certified goes through a certain level of test and should be able to operate reliably. It should be seamless. So when I say seamless, it should be interoperable across multiple devices. It should have unified structure so that it is portable across ecosystems. So yeah, Another important aspect is security. So it should be secure. So Matter addresses it with authentication before joining. So each and every Matter device is put with a unique credential, which is called DAC, and it is actually checked whether it's a valid DAC before the device can actually join any Matter network. Then there are encrypted communication. Whenever there is a communication between two Matter enabled devices, always encrypted. And then if you find, suppose, vulnerabilities in your current device or your firmware, there are provisions for OTA for Matter devices to be able to bring in those security fixes through an upgrade. It's defined on an open and collaborative methodology with implementation first approach. So there is an open source GitHub repository which is contributed by most of the founding members, with all of the founding members, I would say, and it's actually very well in shape. And then, of course, it's defines the standard. So it is built on top of IPv6, and it also talks about supporting the different protocols, right? So and it shows protocols which are pretty standard, which are used, which are well defined. So it uses Wi-Fi as the main wireless protocol, as well as Thread for mesh topology kind of networks or very low power devices. And then it also has Ethernet option. These are for communication. And then it also requires you to have BLE for commissioning. When I say commissioning, it basically means onboarding of the device onto the Matter network. So let's see what the specification, what does Matter cover, right? So first and foremostly is the specifications. So the specification is basically driven and defined by the Matter Alliance members. We have active meetings and discussions, as well as member meetings in which they understand the current progress and what is the market needs, market trends, and then they include what all devices needs to be in the specification, what all modes of operation, etc. Right? So yeah, so they define and drive the specification. Just last week, Matter released Matter v1.1 specification, which is an update over the 1.0, which was released in October 2022. So yeah, so as you can see, it has committed to its biannual specification release. So you should see another release in fall of 2023, which should be Matter 1.2. So yeah, so it's being continuously being worked upon. The next thing which it brings is the implementation, which is in the open source available on the chip repository on GitHub. It has a platform independent implementation. It has reference examples for application, as well as a mobile app reference. So everything is there as a skeleton available to start building devices, and not focus much on the implementation part of it, but more focused on the application development part of it. And then lastly, it brings you a certification program. So when I say certification program, it provides the labs, the test specifications, the certification framework, as well as certification program via certification labs, which are already defined and live. So yeah. So how will it help, right? So we discussed the problems, we discussed what it brings. So how does it help? Right? So if you talk about consumers, right? So yeah, so it is focused on simplicity, which means focused on ease of use for end consumers, with features like multi-admin support, which brings easy interoperability between different devices, which basically means that if you have a Matter-enabled device, you don't have to worry about whether it will work in my ecosystem. It will work in any of the Matter-enabled ecosystem, and it can work in multiple ecosystems together. So it solves a lot of headache from you to operate the device or buy what you want to buy, right? Then it adds options of automation possibilities, like features like device-to-device communication. So your two Matter-enabled device can directly talk to each other without going to the cloud. So they can do some innovative automations, like whenever there is a door sensor, which is senses that there's something happening, or your occupancy sensor that you just entered home. There could be an air condition which is switched on, or anything. I mean, it depends upon the application and the device makers, right? And then there are a lot of privacy concerns as well, so which are also handled because when you try to share devices previously in other ecosystems, you either share the device, which full access, and do not share the device at all, right? But now if you share the device, you can actually tell what all devices you want to share, what all features of the devices you want to share. And of course, as I said, it also has an option to operate even without the connectivity to internet. So the devices can talk in the local network, and that means people with privacy concerns can sleep with a peace of mind. Then for device makers, as of course, it eases the deployment as well as development phase. It's a single ecosystem to support instead of worrying about how many multiple ecosystems I have to go into and integrate into my device. So, of course, which means that the engineers have a lot of more time, which means there is scope for innovation and time for innovation for engineers to work on and put in new things, whatever they want to do, they can do. There are features like, as I said, device to device communication. So think about it. There are a lot of ecosystems who are also trying to do things around it. We will talk a little bit about it later. And then, yeah, it has definitely reduced costs and delays by enabling only a single ecosystem for the device maker, so which is pretty good. And then from the ecosystem point of view, interoperability comes out of the box. So the setup is simple and unified across the ecosystems. So you don't have to worry about how what vendor implemented what. And then it's more scalable and easy for adoption across multiple users. And then since it's an open source development, it provides a standardization of implementation. Okay, that's all on introduction to Matter, I would say. Basically, what it is, why it is. Now we will talk a little bit more about the Matter network, the types of devices it has, the transport protocols, how to choose it, and what are the devices supported in the current implementations or the specifications which are released. Right, so let's first talk about the wireless protocols, right? So there are two wireless protocols which are currently supported on the Meta network. So the first is the Wi-Fi. So Wi-Fi is, I would say, the most widely adopted and available wireless protocol in the home, right? I think there would be hardly any home, at least in major cities or countries, where there is no Wi-Fi, right? So definitely it's available and deployed across, and the infrastructure to communicate over Wi-Fi is available. So that's definitely a big plus. Then it has direct access to internet. That is a good thing to be there because it is required for OTA upgrades, remote controls, device management, these kind of features. Although, as I said, that it's not required for Matter to work to have internet connectivity, but of course there are certain things which require them to have occasional, if not always, right? Of course, it has much higher bandwidth for applications like cameras and stuff like this, which require high bandwidth, are definitely on uh, Wi-Fi enabled protocol. And then traditionally, it is thought that wall plug devices should be Wi-Fi enabled um, because of the need for frequent wake ups to stay connected to the access point. But yeah, Wi-Fi 6 is there. Wi-Fi 6 has a feature called target wake time, which basically enables us to have even battery operated certain types of devices to be battery operated, like sensors, which do not require you to have um, frequent connection to the network, right? So you can stay much longer on the lowest power mode. So yeah, that's on the Wi-Fi side. The other is the thread. So thread is the mesh topology, I would say, on the wireless protocols which are supported on Matter. It definitely has a lower current consumption, and that's a big advantage for it. It can have up to 300 devices on a single network. Um, it requires a thread border router to connect to the cloud. So yeah, so these are the two wireless protocols which are defined. Now let's talk about the different types of Wi-Fi devices. So as we just talked about, so Matter actually defines four kinds of devices. The first is the Wi-Fi end device, which is of course means it's the end node which connects over Wi-Fi. So typical examples would be wall-powered electricals, home appliances, media devices, security cameras, etc. The next would be a thread end device. So this is, as the name suggests, it's an end node device which connects over thread, typically used for battery operated sensors, locks, switches, etc. But yeah, it can also be for wall powered devices. But yeah, typically you would want to use it for battery operated devices. And then there is a thread border router, which is basically a device which is defined to communicate between the thread network and the Wi-Fi network. Currently, it could be implemented in a lot of smart speakers, hubs, media gateways. Recently, the Echo Dot announced that it will be Echo Dot Gen 4 will be a thread border router, and yeah, Google also announced the Google Nest. So we'll talk about the current situation of the thread border routers at home. So it might be possible that you already have a device at home, a hub at home, which is already now uh, upgraded to a thread border router through a software upgrade by the ecosystem players. So yeah, and then there's another concept called Matter Bridge. So Matter Bridge is the fourth type of device, which is basically defined there to bridge existing network topologies like BLE, ZigBee, etc., and bring them onto Matter. Uh, what it requires from the bridge is that you understand what is being communicated over the network and then translate to a metadata model and then push it over to Matter over Wi-Fi network. So it talks one topology on the other side and Wi-Fi over Matter on the other side. Okay, next we have the ecosystem. So how it looks, right? So yeah. So a typical home has a Wi-Fi network which connects to the internet or fiber or cable connections, right? So Matter-enabled Wi-Fi devices will directly connect to the access point of the home to communicate with each other over a star topology or uh, talk to the internet via the access point, right? Uh, the next type of Matter devices would be thread-based devices, so thread-based sensors or endpoints. They communicate to each other over a mesh topology. For communicating between the thread device and the Wi-Fi devices, there is the thread border router, which will talk to thread on one side and Wi-Fi on the other side. And then the third type of network in your home could be other existing non-matter topologies like ZigBee or BLE mesh. And then there would be a matter bridge, which will bridge these devices onto the matter network by translating whatever their communication is happening over to matter data model and then translate it to the matter devices. So this would be a typical Matter ecosystem in your home. If you have a Matter home device, so you have a Matter Wi-Fi network, a Matter thread network, talking to each other over a thread border router, and bringing your existing non-Matter network onto your Matter network over Matter bridges. Okay, so yeah, we hear BLE is a must. So what does BLE do? We didn't talk about BLE, right? So yes, BLE is a must for Matter, but BLE is not used for communicating from device to device or device to controller. BLE is only used for discovery and provisioning of the device. So which when I say that, it basically means it is to onboard a device onto the Matter network. So suppose I have this light bulb which I want to bring into my network. So how do I do it? So when I switch on the device, it advertises it's BLE through BLE that I am there, I am available, and based on the different ecosystems, some of the ecosystems auto detect this advertisement, or the other ecosystems require you to start looking for this advertisement. So based on that, you detect and you do a BLE connection. Once you do the BLE connection, that is when you can now start onboarding the device. I will not talk about the exact detailed flow of how it is done, or this will be taken in a later webinar. But for right now, maybe you can just understand what it does is basically validates whether the credentials which the new device is sharing, whether it's an authorized Matter device or not. And then it will also need to provision it with the Wi-Fi credentials like the SSID and the passphrase, right? So all these communication will happen over BLE, right? So once all this provisioning and commissioning is completed, my device now connected to the access point, I can disconnect my BLE network. And now the BLE is not used in the life cycle of this device. So yeah, the BLE is important, but it is not a communication protocol. It is basically a discovery and a provisional protocol being defined. Okay. Yeah, so the next is the types of devices which are already supported. So in with the V1.1 of the specifications, Matter has released support for a set of devices. These devices include HVAC controls, which could be like thermostats, air conditioners, or fans recently added in V1.1. Could be window coverings and blinds, safety and security sensors, or other kind of sensors, lighting and electricals like light bulbs, switches, plugs, door locks, media devices, as well as the controller and the bridges. So this is, I would say, the first bunch of devices which are currently supported, and support for further devices is expected to be rolled out in future spec releases. Right. So yeah, that would be for the Matter network and the type of devices. Next, we look into the metadata model. So metadata model definition is taken over from Zigbee cluster library and built on top of it. So those who are familiar with Zigbee would be well versed with this topic, but I will still like to briefly go over it. So so metadata model defines the following layers of representation for a Matter device. So firstly is a Matter node, which represents the actual physical device, I would say. Um, the next is the endpoint. So a node could have multiple endpoints depending upon the type of device it has. So suppose we could have a multi-control switch which has one dimmable control as well as one on-off control. So this node would have two endpoints. Similarly, each endpoint, there would be one or multiple clusters which would be based on the function of that endpoint. So say we had this dimmable switch, so it will have an on-off cluster which can on and off the device, and it will have a level cluster which will control the level of the brightness, right? And then for the on-off switch, it will only have a single cluster called on-off cluster. Uh, with each Within each cluster, there is our commands, which are basically the actions the cluster can perform, and then there are attributes, which is basically the state of the current device, right? Let's look into details as an example. So suppose here we have an example of dimmable, a physical matter node which has two endpoints, one dimmable light and one on-off light. So the on-off light is defined as endpoint 1. The endpoint 0 is reserved. We will just discuss later what it is reserved for. The attributes could be for the endpoint cluster on-off, could be on-off, which is the state, whether it is on or off, and then the commands could be on it, off it, or toggle the current state, right? Similarly, the cluster for the level control will have attributes like current level, and then commands could be moved to level. Similarly, for endpoint 2, which is an on-off light, it will have only a single cluster for on-off, and then it will have attributes for on-off and commands like on-off toggle. The endpoint 0 is reserved to have some basic information about the cluster, the access control list clusters. Access control list is important to understand. So when you share your device with a second ecosystem, what all accesses are provided are part of the access control list. And then some network commissioning cluster like the Wi-Fi SSID and passphrase, and all those are stored on endpoint 0. So yeah, so endpoint 0 is basically reserved for maintenance or management. Okay. So the next are the client server clusters that we talk about. So suppose here we have, so every Matter cluster is defined as a client and server, and when we bind them together, so a client and a server gets binded together, right? So that's how. So suppose we have a dimmable switch, which is a node, and then we have a light. So a dimmable switch has two clusters, on-off client and level client, and those get binded to their corresponding on-off server and a light server, right? Similarly, we have a three-gang switch on which has three clients, but one of those on-off client can also get binded to the same node light. So basically now two client clusters can be binded to a single server, which means that they can both control the same light. And the same node could also actually bind to a totally different node, which here could be these on-off clients on the three-gang switch could be talking to an on-off server on the two wall plug server unit, right? So yeah, so it's basically you map the client and the server. Now we will talk about a few key features which are defined in Matter, uh, basically multi-admin, device-to-device communication, and some security aspects. So multi-admin support. So multi-admin support, I would say, is a foundational feature in Matter, and this is the feature which basically helps us to provide the interoperability. When I say interoperability, it's just not that it allows you to work over multiple ecosystems. It helps the Matter device participate in multiple ecosystems simultaneously. So you can control the same device from multiple ecosystems as well as see the current state of the device being reflected if it is changed from any other ecosystem as well. Users can control which device they share with which systems on individual level and can easily add and multiply multiple devices to a new ecosystem to try out new experiences. So suppose how it works, right? So just an example, what it means by multi-admin. Suppose we have a light which is working on ecosystem A, so it has a switch which can control it, and then you can also have a phone app which controls the light. So all good. But now I want to try out a new speaker which is announced in the market, but oh, it's on a different ecosystem. No problems. You can add that ecosystem to your Matter network and do use the multi-admin feature to put the same light also on a couple of that ecosystem. So now you have the light which is now available on both the ecosystems simultaneously, and you can control it from your phone app and the switch through ecosystem A, whereas you can control it by your voice assistant from ecosystem B. The next point I would like to talk about a little is device-to-device communication. So device-to-device communication is basically meaning, as I said, it talks between two devices directly without going through the server or the cloud, right? So it's directly over the local network, and there is no intermediation or a hub required to communicate. So if it is thread-based, they can directly talk over the thread network. If it is a Wi-Fi based, they directly just talk over the access point because, of course, Wi-Fi is a star topology, so it all have to talk to the access point. Um, so there are two kinds of bindings for device-to-device communication. So the first is called the synchronous control. This is a pretty standard control, I would say. So suppose I have a light, which is has an on-off server, and then I have a node switch, which has an on-off client. And then when I want to bind, it has also defined a binding server because it needs a switch needs to bind to something to operate, right? So of course, right, yeah. So then when I'm doing during the binding, I need my phone app or any controller who can do this binding. So for example, we use the phone, and then the phone is able to bind the device and tell the node switch that okay, your on-off client will be binded to the on-off server of the node light, right? And the other way of device-to-device communication is through asynchronous notification, right? So in the synchronous control is basically whenever there is a physical work on the client cluster, it will be reflected on the on the server cluster, right? So when I switch on the light, it will basically tell the node light, okay, you need to switch on, and then it tells back the status of the device. But asynchronous notification is something different. It's a new idea or a concept. So asynchronous notifications, so once you bind the two devices, right? So suppose here we bind a node sensor, which is a sensing server, and a node thermostat, which is a sensing client, and we bind the thermostat to subscribe to the node sensor, right? So once this has happened, after this, there is no longer a need for the intermediation. So the phone app can go, you can go out of the house, it doesn't require. But now the thermostat has subscribed to any notifications from the node server. So whenever there is an activity on the sensing server, it will send something, it will notify, and it will just keep reporting. So it's only just one time you subscribe, and then you get reported about it. And a lot of ecosystem vendors or players are doing something intelligent across it. We will briefly talk about it in the current ecosystem status. Let's talk briefly about the security model. So Matter security model is basically consistent, I would say, consists of at least three broad categories, I would say. So firstly is the distributed compliance ledger, right? So it's the DCL. So what is a DCL? So it's basically a cryptographically secure distributed storage network based on blockchain. And what it allows is it allows the CSA and authorized vendors like the device maker or the chip vendors or the certificate providers to publish information about the Matter devices. So the kind of information which gets stored onto the DCL is checking for device certification compliance status, verifying attestation of the DAC certificate by tracking back to SPA, getting commissioning instructions, links to manuals and product information, um, can check for OTA status and upgrades of the device, whether there are any. So yeah, so DCL is actually used as a central logging machine, I would say, right? Then it's very important. So all the security communications happen using the public key infrastructure known as the PKI. So Matter uses ECDSA-based certificates for signing and authentication. It also uses encrypted communication over the network, which is also based on PKI. Lastly, it has the access control list, which is the ACL, which is I briefly talked about earlier, is a list which specifies who, which means which NOC or node operational credentials can do what on this Matter device. So basically, it is able to control you share the device with all ecosystems and what are the capabilities you share with them. So yeah, continuing on to it. So we have basically defined two types of certificates in Matter. So this is basically more on the PKI certification and the NOC credentials. So yeah, so firstly is a device attestation certificate, which is called DAC, which is basically the identity of the device. And then the second certificate is the node operational credential, which is defining the access control list, which also is also defining whom does the device talk with, basically. So which all ecosystems can the device talk to and what all features are exposed on them. Okay, next we will talk briefly about what is the current status of Matter adoption and the support on the various ecosystems, right? So if we go about the current status, so we are right now more than 300 members in the Alliance, actively participating in their meetings, contributing towards the open source development, all the specifications. As I just mentioned, the specification V1.1 was just released last week on 18th May and are now available. So there are frequent upgrades coming up which is good. The chip tool project has continuous development, a lot of chip vendors, ecosystem vendors, all are contributing, device makers, all are contributing towards the project, and which is having a good shape, which has multiple ready examples as well. The certification labs are live, working tirelessly to keep certifying devices actively, and there are just released along with the specification v.1.1 matter. CSA announced that there are 1,135 new products certified by the Alliance since the launch in October 2022. So yeah, so it's really happening. It's really there, and yeah, it's, I would say, ready for already being adopted quite widely. Next, we talk about the status of the ecosystem side. So there's so many ecosystems, so we just choose to have three of them right now. Just give you just an idea about where everything is going and how well it is being adopted. So as you can see, right, so Alexa has more than 100 million eco devices which are Matter enabled across 20 models. So almost all eco devices of second generation and onwards are Matter enabled. They recently rolled out the thread border router implementation as well on the Eco 4th Gen, uh, as well as the support on the iOS app, as well as Android app support was there since quite some time, but just in May, they have announced the support for Matter devices on the iOS app as well. Then I have one column here which says differentiation. So these ecosystems not just supporting Matter, but they are doing something different as well, right? To provide the differentiation factor across each other, right? So what Alexa has done is Alexa has this, or Amazon has this frustration-free setup. So in this frustration-free setup, what you could do is basically once you are buying a device from Amazon.com or Amazon website, web store, you can actually select for frustration-free setup, and the device automatically is already added onto your Alexa network once it's shipped. So once you plug in the device, it's really onboarded onto your ecosystem within seconds, right? So that's really the frustration-free setup. Then, as I said, there is this Alexa Ambient HomeKit and Alexa Connect Kit for Matter, which are there being developed to simplify Matter development, and then there would be a Zigbee bridge rollout sometimes. Similarly, the Google is also doing this home away intelligence. So this home away intelligence and the Alexa Ambient HomeKit, these are both using the device to device communication. I mean, they are trying to use the device to device possibilities to basically help you or device makers to subscribe to these services, which will basically notify you about the status of the homeowner's current view, right? So it could be whether the homeowner is at home or at away, or is it he or she on a vacation, and then you can take appropriate actions what you want to do on your automation front, right? So yeah, so these are some things which these ecosystems are trying to do to differentiate within each other and provide extra value added services on top, right? Similarly, if I go to the support, we see for Google Home, there are pretty much a lot of devices which are there already supporting Matter Hub, as well as thread border router rollouts happening on Nest Hub, as well as Nest Wi-Fi Pro. Also, Google announced in May this year that the iOS app will also now support Matter. And then, of course, the Apple HomeKit also has most of its Apple HomePods or Apple TVs or HomePod Mini, all of them supporting Matter Hub. Yeah, this would be the status. From Espressif point of view, the current status, I would say, is pretty good and impressive, I would say. So we have multiple customers who have certified products in the market. there are more than 60 Espressif power devices on the Matter certified list on the CSA website, and these are for both Wi-Fi as well as thread end devices. Um, Espressif also has the only open thread listed RTOS based open thread border router. We are also now a CSA approved PAA to provide DAC certificates. And ESP32H2 and ESP32C6 are both Thread 1.3 certified as well. So overall, I would say Espressif is pretty decently doing or leading the front on Matter implementation and services which we provide. So just I would like to take some time now to tell you a little bit more about our product offerings on Matter. So, firstly, as I described before, right? So there are currently four types of Matter devices which are defined in the specification. So Wi-Fi end device, Wi-Fi thread end device, a thread border router, and a Matter bridge. And uh, Expressive, we have solutions for all the four. So that's why we try to say we have a comprehensive Matter solution. So all our ESP32C and the S series products are possible to be have a Wi-Fi end device. Then the ESP32H2 and the ESP32C6 are already supporting thread end device and certified for thread 1.3. And then we have solutions for the thread border router as well as Matter bridge, which are available on our GitHub repositories as well as listed on the openthread.io website. Yeah, so just to give you a list of the products which support Matter over Wi-Fi. So the ESP32C5, ESP32C6, ESP32C2, C3, ESP32S3, and the ESP32. All of them support Matter over Wi-Fi, and they are already supported on the repository called ESP Matter SDK, which is our SDK built on top of the Connected Home IP SDK, which will support Matter over Wi-Fi. If we talk about Matter over Thread, so the ESP32H2, which is Thread ZigBee and 802.15.4 as well as a BLE chip, definitely supports Matter over Thread, but also our new product lines, which is the ESP32C6 and the ESP32C5, which will be coming out soon. They also have support for the 802.15.4, so customers who are wanting to develop Matter over Thread can also use these chips. And then for the thread border router and a Matter bridge, so we have this nice looking dev kit, which is the ESP thread border router dev kit. It has basically a ESP32S3 and a ESP32H2. And Yeah, so basically the same dev kit can actually be used for the thread border router as well as the Matter bridge. But having said that, it's not just limited to this board. You can actually use any of the ESP32C and the S series, which I've just shown you as the Wi-Fi side, and the ESP32H2 over SoC to connect them over UART and then develop your Matter bridge or thread border router applications as you want. To briefly talk about the ESP Matter SDK, so basically the Espressif Matter SDK is built on top of the open source Matter SDK. It's fully supported with the ESP IDF. So yeah, what it does is it simplifies the APIs further from the open source Matter SDK, so which basically brings rich device types supported on commonly used peripherals are already available. There are production ready examples which you can directly actually use to start building your application and your devices, or you can use them as the base to enhance and add some features. Yeah. And then, of course, the tools and utilities for security, manufacturing, and production are there, as well as the support for all standard debugging capabilities as is with the ESP IDF. So these are the device which are supporting Matter. But now we have a comprehensive solutions overview. We will not discuss more about that, I think, in today's session, but we will talk about them briefly over the next upcoming session. So, as I said, we have build your own Matter device using Espressif Matter SDK. That's actually the part of the next talk, our session 2. It will talk majorly about building your own Matter devices either over Wi-Fi or over Thread using the Espressif Matter SDK. And then we have a very interesting concept called ESP0 code, in which we try to offload all the development and the complexities which arise for Matter development, all the certifications, as well as the maintenance of the DAC certificates, etc., out from the device maker's view, and provide them with pre-provisioned, pre-programmed modules which are Matter capable to directly plug into their product. Then the next is the Espressif DAC pre-provisioning service, which is basically pre-provisioning of the modules when we ship you. So you still have your own firmware development and everything which you want to add to your own application, but you still don't have to worry about the DAC provisioning complexities to add to your manufacturing line, and you can simplify your manufacturing to be exactly same as before without having to change it for adopting it for Matter. And then we, of course, also have a Matter certification assistance service in which we will guide you. We have pre-negotiated rates with some testing laboratories which can help you, and we can guide you on the test suite or a reduced test suite which you should run. So we will completely guide you on getting the certification for your device. So I would say that is all I had to share today. I hope it was informative and answered some of your queries or questions which you had in your mind. If not, of course, we are here to answer your any questions. I would just like to say that we will try to answer the questions over the next 10 minutes or so. But if you still have any further questions, you can still post it on to our YouTube link, or we will share link. If you don't want to post it on a public forum, you can write to that form and send us your questions. We will try to answer them as soon as possible. Lastly, just a reminder that this is the first session. We have a couple of more sessions coming soon. So we have a session on 26th of May for building a Matter device, and then on the 30th of May, which talks about the certifications of and the Matter certification flows and the device certificates which are involved in the Matter development flow. So yeah, thank you. Any questions now?
I'm back. Okay, thank you so much for your presentation, Anand. It was really nice to give to our audience, a overview about what Matter is and how important it is for the whole IoT connected devices ecosystem. So before we go to the Q&A, so I like to invite you to subscribe to our channel. So you will be notified by any other webinar we'll have, not only for the next webinars about Matter that we are already planning, but as well for all future webinars. So please subscribe, and you will be notified by us, or by YouTube in this case. So now we'll have a short time for a Q&A session. Please give your not only questions but comments about this presentation or about Matter itself if you're already developing something. So please let us know. And now we'll have a quick Q&A. So thank you. Hi. So we are we are back for the Q&A session now. So we already have some questions in the chat. We already answered some of the questions. So I would like to thank you all Espressif staff that it is answering the question live in the chat. And to join us today in this Q&A, we also have Shubham and Rishikesh. They are directly from India, and also like Anna, he's already here with us. So for the first question that we have here, let's see. Okay, so first question, does Matter have special features when used over a thread network?
So yeah, so I would say no. So the matter specifications have clearly defined the data model, which is regardless of the protocol which is being used on it, right? So yeah, so the device will have the same feature capabilities as running on Wi-Fi or on thread. So yeah.
Okay, so thanks, Anand. And the second question, let's see. Sorry, I'm cropping the question. Just 1 second. Okay, so what is the difference between the conventional open thread border router and the open thread border router which will work on Matter?
Okay, so maybe I'll take this. So ideally, there is no difference between a standard OTBR or OTBR that works with Matter. Basically, what a thread water router does is connects a thread network to other IP networking technologies like Wi-Fi. Uh, just to give an example, so you use your phone app to control a thread matter device. So the phone app doesn't understand thread, whereas the thread matter device does not understand Wi-Fi. So in that case, a thread word router would be required, which translates from thread to Wi-Fi and vice versa. So in short, there is no difference that is required.
Okay, thanks. So before we go to the next question, I'd like to invite the audience to say or to just to share with us if they are already using Matter or if they are trying to use Matter on Espressif chips. So I'd like to know if the audience is already playing with Matter. And as well, like if you can say where are you from, guys. I think we have people from all over the world. So I'm from Portugal. So Anna from Singapore, and Shubha and Rishikesh from India. So if you guys want to say hello from where you are, feel free for that. And for the next question, just 1 second, and there is it. Are custom device types possible to add?
I'll take that one. Yes, you can build the custom device types, but we have to make sure that the apps should understand that. For that, you will have to build your own app. The standard Google Home app or Apple Home app may not support these.
Okay, thanks. And we have one more question here, which is really interesting. Is it possible to run other protocol alongside Matter, like MQTT plus Matter, or maybe I think this extend for any other like protocol?
Okay, so I'll take that. So matter specification only talks about local network, but the implementation does not restrict you to any such thing. So if your current product uses any of these cloud-based protocols, you are free to continue using those in your implementations.
I see. Thanks. So we have people from Italy. Hello, Marco. Hello from Italy. Ciao. And yeah, I think more people from India. That's really nice to see people all over the world. Do you guys have anything to add to the presentation, or is there anything that you'd like to share with the audience based on the comments that we already got?
Yeah, I think I'm just browsing through the comments now. It's yeah, people have shown a lot of interest, and yeah, thanks to Ame and Rishikesh and Shubham to answer them as well. So yeah, but I see a lot of interest, enthusiasm, which is good for the protocol and the community as well. So yeah, let's keep this rolling.
That's cool. So more people, like one from Mexico. So, hola. It's early in the morning in Mexico. So enjoy. I hope you are enjoying the webinar. Pakistan, Sweden. Yeah. So a lot of people from many different places. So before we go, we have one more webinar, actually two more webinars to go, and we have one more session for this webinar, which will happen at 4 p.m. Central European Summer Time, and we have one more session for the building Meta devices on Friday, and then next week we have about the certification. So this series will cover basically everything that you need for start building your device. So if you go to our profile on YouTube, you will see all the live that we have already scheduled. So yeah, let's see if we have any other question from the audience. So can we have a live demo? That's a good question. So how should we prepare a live demo for Meta? Do you have any idea, guys? How can we do that?
So, from the live demo point of view, the next session, building a Matter device, would cover most part of it, wherein we would be showcasing two different aspects. First would be directly trying out a Matter device using our ESP Launchpad with a ready-made binary, and then actually setting up the Matter environment and compiling and flashing an example. And then trying it out with the ecosystem apps. So both of these aspects would be covered.
Okay, that's really cool. So I have one question from Carlos, who is Perceive collaborating with others on Matter. Do you think is the future? Like I think I like to answer this question if I can.
Sure.
So
Yes, wow.
from my perspective, yes, Matter is the future not only because it changed how we interact with the smart devices. So the whole like experience. I'm saying from the user perspective, not the device maker perspective. So just the way that it changed the like how we added new devices to our ecosystem and how we can use many different ecosystems to control our devices. So this is basically what I think is the future for IoT devices, especially when we have this interaction between ecosystems. So I'm not sure if you have anything to add, guys, about this question.
Yeah, so Pedro, whatever you said makes perfect sense. Just one more addition over here. As Matter is backed by all the sections, I would say, like the ecosystem guys, the end device manufacturers, as well as the platform vendors. So it definitely would be the next big thing, in my opinion.
Yeah, so I think buying a smart light bulb would be as easy as buying any other I'd say no connected product because it doesn't
Yeah.
matter
Yeah.
the manufacturer, like it will work.
Yeah.
This is
Yeah.
the beauty.
Yeah, I like to use the Wi-Fi analogy here, right? Because now, if you see, right, Wi-Fi Alliance and Wi-Fi certification has become so standard that you don't think about that. If the device has that Wi-Fi logo, you don't think twice about it being working in your Wi-Fi environment, regardless of who is building your access point or your router, right? So I think that is what Matter will bring to smart home devices, that if it has a Matter logo, you should not be worried about whether it works in your ecosystem. So it's good and shaping up. And as we say, right, based on the current status which we saw, right, we have most of the big players being in it, certifying devices, producing devices. Everything seems to be going in the right direction, I would say.
So, is there any question you guys would like to answer from the audience? Another hello from Italy. Ciao.
Yeah, I think there was one question about zero code modules. So which asked about where can we get the relevant documents and development details. So firstly, I don't know what development you want to do with the zero code modules, because it actually means zero development.
Yeah.
But yeah, to know more about the zero code, you could actually start going into zerocode.espressif.com and start seeing and evaluating your firmware on any of our dev kits for C3 devices. We already have this now in place, so you can try out our zero code development framework there. Um, I think we have now a lot of questions. What kind of data security will Matter give? So, Rishikesh, you want to take that?
Right. So Matter uses ECDSA. So basically, there are two types of secure channels that are established during Matter setup, which is termed as commissioning. Uh, the setup starts over BLE. So a secure session using a proof of possession is established, which is termed as PACE, password authenticated session establishment, and then all the subsequent communication over BLE is over this secure channel. The Wi-Fi credentials are also received over the same channel, and once the device joins the Wi-Fi network, there is a certificate-based secure system that is established, which is called as case, using which the subsequent communication or the operational communication over Matter happens.
Okay, so I think we have no more time for questions. So I'd like to thank you guys, for this amazing presentation, this Q&A session. So thank you for joining. I'd like to thank you, the audience, as well, to be here and ask questions. That's really important for us. So if you have any other question, or if you are watching this webinar in the future, so of course, you are not able to ask here in the live chat. You can ask directly to the YouTube comments. We will try to answer all the questions. And if you don't want to share the question for some reason, like if you are working in a top secret project, please, there is a form link in the video description. You can go just there and ask us your question, and then we will answer back by email. So you are free to share any top secret information. So any final words, guys?
No, I would again like to thank everyone for joining in, and and we will be sharing the slides as well. I think there was one question I just browsed through, so yeah, we will share it in a YouTube comment link when we will pin it, so you can find it later once. Yeah.
Yeah, and looking forward for the folks to join the next session.
Yes.
Yeah, we are looking forward for that. Yeah, so again, thanks, and see you guys in the next webinar session. Bye.
Thank
Thank
you.
you.
Okay.
Bye bye.
Bye.